Alright, so this video I'm going to cover vertical asymptotes, which is vertical asymptotes and horizontal asymptotes are unique to, for the most part, unique to rational functions. So that means like you're not going to have a vertical asymptote or a horizontal asymptote with a quadratic function or a linear function. I suppose you could kind of argue that quadratic functions have a horizontal asymptote because it's shaped like this, or this, quadratics are, so like it's never going to cross this line. But asymptotes are a little bit different from that, and it's really something that we talk about just with rational functions. So, a vertical asymptote, I actually have an example. We did a card sort. This is just one of the cards from the card sort. Just ignore this side. But over here, this is from one of our card sort activities. This is an example of a vertical asymptote. So these lines over here are the actual graph of the function. And this dotted line represents this sort of imaginary line that the graph is never going to cross. The graph is never going to be on x equals 2. So in other words, that's saying that the function, I'll say that this is function j of x. J of x is never going to have x equals 2. So x is never going to be 2 for j of x. And the reason that x is never going to be 2 is because whatever our function is, we're going to end up with, if we plug in 2, we're going to end up with something, doesn't matter what that something is, divided by 0. And that's what this line represents. Because we can't have something divided by 0, and when x equals 2, we do have something divided by 0, so that's why the function is never going to be at x equals 2. So that's the idea behind vertical asymptotes. So now let's talk about how you can find your vertical asymptote when you're given the function. So let's start with something simple. Let's say we have f of x equals 1 over x. So your vertical asymptote is whatever value of x is going to make the bottom down here equal 0. So in this case, if we have 1 over x, then what would make the bottom part 0? So what would just make x 0? Well, that's kind of easy to answer. X equals 0 would make the bottom 0. So x equals 0 is going to be our vertical asymptote. So what that would look like is, I'll just quickly sketch a little graph here. So at x equals 0, so that's this line right here, is x equals 0 down the y-axis. So I'm just going to sketch generally. It would look like this, basically. So it's never going to cross this little line right here. Because if x is 0, which it would be if it was on this line here, then our function would be undefined because we'd be dividing by 0, which we know we can't do. Okay, let's try another one. So let's say, actually let's do g of x. Let's say we have 1 over x minus 2. So what makes x minus 2 equal 0? And whatever the answer is to that is going to be our vertical asymptote. So we can just solve, and we get x equals 2. So that is our vertical asymptote. All right, let's try one that might be a little bit more complicated. So we'll call this h of x. Actually, before we do that, let's do, okay, so what if, so up here we had 1 over x minus 2. What if we had 5 over x minus 2? I'll just make a line here. Separate. So if we have 5 over x minus 2 instead of 1 over x minus 2, what do you think is going to change about our vertical asymptote? Well, the answer to that is it's not going to change, because still, if you plug in 2 here, you're going to get 0 on the bottom. So our vertical asymptote is still x equals 2. All right, so now let's try something a little trickier. We'll say j of x. Let's say 1 over, let's say x squared plus 5x plus 6. Now, still the same idea. We want to figure out what makes the bottom equal 0. So we can say, okay, x squared plus 5x plus 6, if that equals 0, you can just solve. And now think back to math 2. How would you solve this equation? And the answer to that, hopefully, is you would factor. And if you factor this, you're going to have x plus 2 times x plus 3. Remember, we want two numbers that multiply to 6 and add to 5. And that is 2 and 3. So we have x plus 2, x plus 3 equals 0. And now once we have that, we can easily see that x equals either negative 2 or negative 3. So now that tells us that our vertical asymptotes are negative 2 and negative 3. So it is possible to have multiple. And even if the top of this function was something really crazy like x cubed plus 7x squared plus 15x minus 64. Even if we have all that, we don't care, because the bottom is still the same. The same thing is going to make the bottom 0. So we don't care what's up here. So we would get the same answer here as we did when there was just a 1 on the top. All right. Yeah, so hopefully that makes some sense. Just let's look again one more time at, this is what a vertical asymptote would look like. The vertical asymptote here is at x equals 2. So that's what the vertical asymptote would look like. And we'll look at horizontal asymptotes in the next video.